Good morning, evening, afternoon, depending on your time zone, and welcome to Community Central Tech Tuesdays. Today we are going to have Chris Caligari showing us how you can run Windows applications on Kubernetes. As you probably know from all of the marketing from the good folks at Azure, you can run Kubernetes on Windows. But this is about doing things the opposite way, running Windows applications and Kubernetes on Linux in order to migrate your old applications or for whatever other purpose. Before we get started, a few other housekeeping notes. Like usual for Community Centrals, we will be taking a bunch of questions, but you need to ask your questions using the Q&A pane on your browser. So go ahead and ask a question in the Q&A pane. If you're an attendee and you see a question that you are interested in, please vote that question up. We'll be taking the top upvoted questions. This whole session is live streaming to both Red Hat staff and the public. This does mean for the Hatters who are on here, please ask questions that are suitable for the public rather than, say, product planning questions. And then this whole session will be recorded and will be available on YouTube in the Red Hat Community YouTube channel. By the way, for future Community Centrals, we also have a new public web page at communitycentral.tv, which lists all of our sessions that will be open to the public as they come out, and then an index of our YouTube videos. So with that, I want to welcome Chris Caligari from the Kubevirt team, who is going to show us how to migrate your Windows applications to Kubernetes. So, Chris?
Hi, everybody. Again, my name is Chris Caligari, and I'm a member of the Kubevirt community team. And I'd like to introduce you to the Kubevirt project and show you how easy it can be to migrate a Microsoft Windows guest virtual machine serving a web application to a guest virtual machine orchestrated by Kubernetes via Kubevirt. For those new to the world of Linux containers, Kubernetes is a platform and project open sourced by the Container Native Computing Foundation. It's used to orchestrate and scale Linux containers along with their configuration, network routing, data associated with their application payloads. Kubevirt is an open source project that extends Kubernetes to allow virtual machine workloads to run natively alongside container workloads. In other words, it provides a simple interface for apps that require traditional VMs. That said, Kubevirt is actually a modular ecosystem with several components. In this demo, I'm going to focus strictly on the Kubevirt core, the component that actually allows users to define and run VMs, and the containerized data importer, CDI for short, a component that facilitates data-related workflows like manages VM disk images. CDI will land incoming data into a persistent volume with a persistent volume claim. Before I begin, let me just take a few seconds to explain my demo. I have a Kubernetes cluster pre-deployed along with Kubevirt and CDI. Our source is going to be a Microsoft Windows 2019 guest, and running inside of the guest is my favorite .NET app called Jellyfin. Go check those guys out at jellyfin.org. It's a really awesome app used to manage your media library. The guest is running on my Apple MacBook Pro and uses Oracle VirtualBox as the hypervisor. I picked Oracle VirtualBox very specifically. It's been my past experience that developers run various platforms such as Apple and Linux and even Microsoft Windows to develop their applications. And VirtualBox has shown to be an excellent cross-platform hypervisor. Okay, so I pre-recorded the demo, various progress meters are sped up, and we're not waiting an hour to just watch progress meters. And let me start that video right now. Okay, let's begin by running a simple application test. We'll start up the guest. And let's get logged in. From here, we can open up Firefox and browse to the local host name at port 8096. And we see a functioning application. Looks good. Okay, from the local laptop, I can browse to the local host at the exposed port 30,761, and we see it. Okay, let's get everything shut down. Very good. The virtctl command is a helper command used to interface with the Kubevirt API. Here I will use it to transfer the guest virtual disk image into the cluster via the Kubevirt CDI proxy. Uploading this 13 gig disk image will take over an hour on my lab network, so I'm going to do some video editing magic to avoid watching a slow progress meter. The kubectl command is used to interface with the Kubernetes API. Here I'll use the cluster info argument to verify connection to the cluster, and the get nodes argument to verify we have a node to run things upon. Get PVC will show Kubevirt CDI has indeed created a persistent volume claim. Describe PVC describes the various aspects of the claim, including a successful upload log. Get PV shows the volume backed and claimed by the PVC, and describe PV provides the exact path of the host path-based volume. I can now create the virtual machine definition, which is a Kubevirt custom resource describing a virtual machine. Before creating the VM, let's do a quick review of the manifest. We see kind virtual machine is defined, 1 CPU, 2 gig of memory is defined, a disk is defined and connected to a Kubernetes volume. Running option is set to true so that Kubernetes API will always ensure the VM is running. The VM will start immediately and also restart automatically on another node in event of a node failure. A running virtual machine is modeled by another custom resource, a virtual machine instance, that Kubevirt will use to create a Kubernetes pod. The pod will include a container in which a QEMU process will run the VM. Once we see the guest running, we can use the virtctl command to establish a VNC connection to the guest console. Same as before, log in, open up Firefox, browse to the local host name at port 8096, and we see a running application. The final step is exposing the application port in the same way I would expose a typical Kubernetes workload. In this case, I'll use the same exposed port for a node port type service and also include label special key. Kubernetes will use label special key to assign the service to the VM. Now opening up Firefox on my laptop and browsing to the cluster endpoint and exposed port shows the application is accessible on the general network. It's as simple as that. Thank you. And that's my demo.
Okay, I'm checking to make sure everybody saw that. If they didn't, we're just going to go with the recording because I think we captured it for the recording this time.
Okay.
So we have lots of questions. If you are ready for questions.
I'm ready for questions, and I have my live environment right in front of me, so I'm happy to share my terminal, and we can all hack away.
Cool. Okay. So first question from Anthony, who says that used a lot of different technologies there. Could you rattle off quickly the various things that went into making that happen?
Oh my gosh. I was working on this video up until midnight last night trying to stitch everything together. So originally we wanted a Windows platform with an Oracle VirtualBox hypervisor and a Windows guest. We have a hardware allocation issue, and we ended up having to run everything from our laptops. So the start of the demo shows my Apple MacBook Pro running VirtualBox and running a Windows guest, and then interfacing with another server that's running Fedora 32, Minikube's spin of Kubernetes, and I have enough disk on that server to run a single virtual machine. So it's a bare bones demo, but if you're an application developer, this would be a similar scenario. You would develop code on your laptop, launch a virtual machine that's packed with your application, and test your new code. Check that code into a repository, and cut another virtual machine and QE and then release that virtual machine. I've seen this a handful of different companies, including at Red Hat. And so as we try to create workarounds for our hardware difficulties, we're like, oh yeah, this is a similar scenario as another team.
Cool. Okay.
And I wish I had a slide and an architecture diagram, but we were just so tight on time. We didn't have time to create anything official.
Okay. So Flavio wants to know if you can talk a little bit about the experience of installing Kubernetes in your demo cluster. You just talked about it a little bit, but do you want to go through what's required to install it?
Sure. I have a single start command that starts out Minikube, and I use Podman and I use Creo, and it runs fantastic. I'm happy to share the exact start command. Give me one moment here.
Actually, if you want to share your terminal, you could maybe show what you have there.
Okay. Screen sharing. So this is my start command. Okay, yeah, I'm shared. Okay, so this is my Minikube start command. It's pretty complicated because I am transferring a rather large virtual disk image into the cluster. Normal container workloads are like 100 megabytes, and I'm transferring 13 gig into the cluster. And we also have to do a disk image conversion using QEMU image, and that's part of the CDI application. So we'll need twice the amount of disk space, and then I double that with 50 gig. So Minikube start, driver equals podman. That allows me to run Kubernetes as my normal non-root user. We're using Creo as the container runtime. Disk size 50 gig. Memory is 8 gig. You have plenty of memory to run several virtual machines. So things get a little strange here for my lab. I alter the Linux network bridge to only allow several IPs just for DNS reasons to get that kdes.example.com DNS domain name to work. So I'm running a /29 network. It only allows me 7 IPs, 6 IPs. I assign my API server names to kdes.example.com. And that allows me to obtain a certificate from Let's Encrypt. So I have an official certificate from that's CA signed for kdes.octocube.co. Once Minikube is up and running, we see our service. I have Kubevirt and CDI are all pre-installed, and I installed this manually. The latest version of Minikube has a Kubevirt add-on. So Minikube add-on enable Kubevirt. It's as simple as that to install Kubevirt. And that will be the command to get everything created.
Okay. Christopher wants to know, have you found VirtualBox to be acceptable performance-wise? Like, is it something you would actually use in production or just for demos?
Yes, it's very performant. The application I demoed is called Jellyfin, and it's a streaming software for digital media. It streams 4K movies to my television downstairs. Perfect. No artifacts on the video. I can go on about different applications running within VirtualBox. Red Hat developed the Red Hat mobile application platform and used VirtualBox as our testing platform. So it's very performant. And same with moving the virtual machine into the Kubernetes environment. Not sure if anybody caught the difference in virtual machine sizes, but the original Oracle VirtualBox guest was a 2 CPU, 4 gigabyte of memory VM. and I dropped that down to a 1 CPU, 2 gigabyte of memory VM within the Kubernetes environment. And it still runs good, still runs my application great.
Okay, cool. Igor wants to know the status of live VM migration between compute nodes.
Oh, darn. I wish I would have been able to get to that part in our demo. I'm a hardware constrained and I only have one server to work with. So that means only one node within the Minikube Kubernetes environment. I didn't get a chance to scale the demo out to doing live migration. Kubevirt will do live migration, and so yes, that's a feature that is available.
So
it's not in this demo.
Right, you have to use the Kubevirt Cuddle interface to do live migration, though, right? There isn't any way to do that through the standard API.
It should be available.
Yeah, we have to use virt control for it, right? For migrate and all the other things.
So this is for manual migrate. If I yank the power cord out of my node and it goes down, the API will live migrate, not live migrate. It will spin up the virtual machine on the adjacent node.
Okay, cool.
So we do have HA capability, and that's all.
Nice.
That's all in the run format. I have in the manifest under the spec running true. The API will ensure that virtual machine is always running. So if I lose the node, the API is going to see node down, virtual machine down, and it's going to spin it up on the adjacent node.
Cool.
Or another available node.
Nice. Well, that would probably have some limitations with things like if you're running SQL Server.
It'll have limitations if your application crashes the system and you go into a crash loop.
Mm-hmm. Okay, cool. Ravi Shankar wants to know what VM formats are supported.
As far as virtual disks?
Yeah, well, what's supported other than VDI? Is QCOW supported?
Yeah, virtual disks. So we have part of CDI is QEMU image convert. So we're going to convert all the QEMU supported disk image formats into a raw disk. So for tasks like encryption or snapshotting, we're going to rely on the cluster storage capabilities for those functions. And of course, raw disk format is going to give us the best performance.
Speaking of performance, Tom wants to know what the performance implications are of doing this much abstraction. Like, he wants to compare, and obviously you don't have comparisons for all of these things. Windows on Kubevirt on Kubernetes, a Windows app on a Windows guest OS on OpenStack versus in a native, Linux container application on running on Kubernetes or OpenShift. Have you done? Has the Kubevirt team done any comparisons? Yeah, has the Kubevirt team done any comparisons? Is the real question of running apps in various environments and for what the overhead is.
I'm going to have to take that one offline, and he can interface with us directly. And I'm pretty sure we have some metrics in our repo somewhere. I'm too new to the community to answer such a wide question.
Okay.
Is that a good politically correct answer?
No, no, it's fine. It's fine. I don't know. I don't know of any performance tests we've done either, actually.
Yeah,
Um, the
it's such a it's so variable. My demo was on a Core i5 16 gig machine, and there's some just monstrous CPUs out there right now with NVMe disk, and so uh, it's just too wide of a question to answer with data. And
yeah. Well, and for a lot of applications, there isn't a comparable option, so
mm,
it's a little hard to compare it. So,
mm.
some quick questions. John wants to know what version of Kubernetes or OpenShift were you using?
So community. This is upstream to OpenShift CMV. So we really try and focus on community versions of things. That said, this is Minikube, which is an easy way to bring up Kubernetes, and here's my versions. I believe I'm pretty much latest and greatest.
Yeah.
1.18.3.
Yep. And for those of you listening who are running Kubernetes, if you are running 1.118.1 on the server, please upgrade. There's a patch security hole. Okay. So Bernie says he might have missed this in the video. Did you actually convert the disk image format, or was Kubevirt actually running VirtualBox image?
So it's in line. If see if we can still see it. PVC. Okay, so what happens is when you run the virtctl upload image command, you'll see a PVC get created, and then you'll see another PVC gets created called testvm-scratch. Your data is going into the scratch PVC, and then QEMU image convert command is going to get run against that virtual disk image. And then the output of that command is going to go into the production PVC. So the VDI is getting uploaded, but what's actually going to get used will be a raw disk image. The conversion is in line.
Okay. And then one more question, and I'm actually going to, Igor asks a question, and I'm going to extend it because I have a related question. So Igor asks whether or not it's possible to change the backing storage class. I'd actually like a more quick capsule thing of how storage works in general. I mean, you've got a raw image there. Mm-hmm. So if the application itself needed storage, like say if I was running SQL Server under this, would I have a separate PVC for that storage, or would it still be all on the raw image storage?
Yeah, there's a bunch of different ways you could handle that. So just for sake of demo and speed, I used host path storage class, and I did that because my host only has local storage, but it's common for SQL servers to have multiple disks attached to a virtual machine, and those disks can be uploaded into their own PVCs, and then so this is my OS PVC, but it doesn't have to be an OS PVC. It can be your application disk that gets uploaded into this PVC. Once you get into defining your virtual machine, again, I only have a single disk assigned to this VM, but you can easily scale. You can easily scale this YAML list out to multiple disks, as well as the attached volumes. and then your virtual machine will come up, will launch just like it launched in the virtual environment in VirtualBox or VMware. Does that make sense?
Yes. So let's do just a couple quick. We're pretty much out of time. So I'm going to echo Jay, who put his question, which is, please publish a blog post on how to get this up and running for people who have the RAM and want to try it for themselves.
Sure. We actually do have a blog post.
Cool.
And this video follows that blog. So come out to kubevirt.io and click on the blog link, and it should be our latest blog entry.
Okay, and I will link that blog entry from communitycentral.tv so that people can find both the blog entry and the video together.
Okay.
And we'll have that. And that is, yeah, go ahead.
Oh, I was also going to mention this video is posted to our Kubevirt YouTube channel as well.
Cool. And it will be posted to communitycentral.tv as soon as we edit it for the technical glitch. So, given all of that, we are at time for this. Thank you very much for that. It's super cool, even for somebody like me who's been watching this as it comes along, and how we've improved Kubevirt and made it a full environment, and for a lot of our audience for whom this is all new. For anybody who didn't get their question answered, the Kubevirt team is available on the Kubevirt community mailing list. They are available on the virtualization channel on Kubernetes Slack, and probably via other mechanisms as well. If you work for Red Hat, you can reach them internally on Google Chat, and Kubevirt on Twitter as well. There are lots of places to ask your question if you didn't get it answered on the video. Next week, we will have 2 hours later than this time slot, we will have Dusty Mabe from the Fedora Core OS team talking about where Fedora Core OS is today, because it's been a year and a half since they merged Fedora Atomic and Core OS is container Linux, and we want to see where it is. So please join us next week for that. And in the meantime, please go ahead and give Kubevirt a try if you have not already. Thanks, everyone.